So now to get the sampling distribution of a statistic, we would need to take all possible samples of size little n from the population. So that sounds good in theory. In practice, we can't actually do that. There's billions and billions of possible samples from a given population. But we can simulate that by taking thousands of samples in an instant using the sampling distributions applet. So again, really interesting to think about that at the time when these things were discovered, they didn't have applets to click a button and do thousands of samples in an instant. They were actually like putting little pieces of paper in a hat and drawing out samples and doing computations by hand to discover these results that we're going to see happen in just a click of a button and in just a few seconds to get these. So we're going to click reset on the applet that we were just on, and then we're going to click 1,000 times, and we're going to click that button 5 times so that we get 5,000 samples of size 10. So again, our sample size here, little n, is still 10. It's just we're going to take a sample of size 10, it's going to compute an X bar. It's going to take another sample of size 10 and compute an X bar. And it's going to do that 5,000 times for us so that we can get a much clearer picture of what this distribution of the sample means looks like. All right, so we're going to reset this applet so that all of our graphs are clear. Okay, our sample size here is still set to be 10. But now we're going to click the button to do 1,000 times. So again, it's going to take 1,000 samples of size 10, and down below on the bottom graph, we're going to get a graph of those 1,000 sample means that it computed. Okay, and I kind of clicked twice, so it actually did 2,000 already. So we're going to click another one to get another 1,000, and another one to get another 1,000, and another one to get another 1,000. So we see now here that the number of samples that have been taken now is 5,000 samples. Okay. And again, the shape of this distribution should be looking very familiar. Okay, so this is the normal distribution that we've been talking about in this particular chapter. Okay, and so it was quite an interesting discovery that if an underlying population, in this case, had a uniform distribution, so that thing doesn't look anything like a bell-shaped curve, but if we take a sample of size n and compute the sample mean, and then make a distribution of those sample means instead of the individual x values, we get this beautiful bell-shaped curve that we've talked about earlier in the chapter. So again, the one in the textbook doesn't match perfectly because they are random samples, but again, we started with this uniform distribution where the mean mu sub x was 25. Okay, our standard deviation here, sigma sub x, is about 14.4309. We took samples of size 10, so there's our little n, and we took 5,000 of those samples of size 10, and so down here this graph is the distribution of our sample means. So let's put this off to the side a little bit because it kind of looks like we just underlined a word there instead of putting a bar above the x. Okay, so this axis up here is an x-axis for the individual values of x. Down here, this axis is our x bar axis. Now, we certainly haven't taken every possible sample of size 10 from this population, but we've taken an awful lot of them. We've taken 5,000 of them. So this bottom graph gives us a very close approximation to the sampling distribution of the mean when n is 10. Okay, when we start with a distribution that is uniform over the interval from 0 to 50. Okay. So this is just a snapshot of that bottom graph. Okay, so again, this is based on 5,000 samples. And again, this axis down here now is our x bar axis instead of an x-axis. So this sampling distribution of sample means also has a mean and standard deviation, and we get new symbols for those. So the mean of a probability distribution, we use the parameter for that, so we're going to use the symbol mu. And then the subscript designates the random variable, which in this case now is x bar. And the standard deviation of a probability distribution, again, we use a parameter symbol, so lowercase sigma. And again, we're going to use the subscript x bar since that is our new random variable. So now looking at the numbers that we have here. So this 24.9223 is the mean of this distribution that is graphed here, which is an approximation for the true mean if we had just kept clicking the button and taking thousands and thousands and thousands of more samples. So in here we're going to say the mean of the distribution of all the X bar values is roughly 24.9223 minutes. So that's our approximation based on these 5,000 samples. And the standard deviation of that distribution of all those X bar values is this 4.5265. That's also in minutes. So again, these are approximations. So let's just put that underneath it here. Why we use those symbols. These are the approximations based on 5,000 samples.